My name is Akshay. I am segment leader for Clean Process and Life Science segment for Camfil India. Just I'll take you through the company first. We are 60 plus years old company, founded in Trosa, Sweden in 1963. Our headquarters is in Stockholm, Sweden. More than 6,000 plus employees. Our current group CEO and president is Mr. Mark Siemens. And we have 29 production sites, 6 R&D centers, and 35 plus countries with sales offices. Our vision is to to phrase our vision statement as a question, which is clean air a human right. And we are actually looking forward for this in UN as well, so that we should consider clean air as good as the water as a human right to the people. It should be delivered to all the people. And our mission is to deliver solution that combine clean air with energy efficiency in a sustainable and profitable way. We are in India. Camfil is also in India. We are proponent of Make in India thing by having two manufacturing site, one in north, one in south. Our head office is at Manesar, and we our presence in India is now more than 4 decades. We are the BIS panel member for developing standards for air filtration in India. So this was about my organization Camfil. Now let's start the topic. My topic for today is clean room guidelines, understanding HEPA filters and their role in contamination control. So this is the basic guideline of clean room when it comes to pharmaceutical as well as for any other, like for semiconductors and all area. And to just give you a brief, we have four different grades in pharmaceutical clean room application. One is grade A, which is generally as a at rest when there is only equipment installed, no running or no operation is going on, and there's no personnel. At that point of time, we generally see the particle count should not get maximum, more than the given subscribed, should not be more than this much range, which is mentioned on the right hand side. If I talk about ISO class 5, which is a grade A area, so the range for zero point 0.5 and 5 micron should not exceed 3520 to 29. So we have different ISO classes for the same. And when we design any clean room in specifically for pharmaceutical industry, the actual purpose is to define it into different sections. One is grade A area, which is a high risk operation area, generally being called as aseptic filling or open vial handling. Then background to that grade area is the second area, which is called grade B, where at rest the classification should be ISO class 5. And grade C area is basically the less critical area where the sterile filtration is being done. And the mostly the requirement is for this particular grade is ISO class 7 and class 8 during at rest and in operation. For reference, you can just check on the right hand side how many particles are allowed as per the classification of 14644 guideline. So similarly, grade D, this is a basic clean area for handling components, and there's no defined classification when the area is in operation. But at rest, it should minimum at least should clear ISO class 8. Now, there are also few classes called class 1 to class 5. These are the critical areas used in mostly for semiconductor area, where they are actually performing the advanced photolithography, wafer fabrication, fab, and lithography base. So for these application, generally the semiconductor industries use ISO class 1 to class 5. And post that, from ISO class 5 to class 8, pharmaceutical industries are using these kind of grade areas. So this is related to the clean room guideline for ISO 14644. Now, what are the key testing procedure? Why do we need ISO 14644 is to, define and to test the clean room environment, as mentioned in the previous presentation by Mr. Sohail. We are actually taking out few of the tests. One is the leak test, which is being done at site during installation of filters to understand that what exactly how many particles are there, and it should actually follow the protocol whatever is given in the guideline. Then we have airflow test, which is generally being done to check the uniformity and if there is any and to ensure there is a consistent air movement in the clean room which is required. Then particle counting, as mentioned in ISO 14644-1, filter integrity to verify whether the filter is actually there's no leak and it is performing as per the integrity of the filter which is being done on H13 or H14. Then we have pressure drop test where we check that the airflow resistance through the filter should operate effectively and there should not be excessive energy usage. To achieve this reliable test result and maintain compliance with ISO 14644, these are the best practices which should we follow during the testing of the clean room. One is use calibrated instruments and certified aerosol generators, perform regular maintenance and revalidation, record all tests for audits and quality purposes. And regular HEPA filter validation improves clean room efficiency, generally maintaining the ISO compliance, and this reduces the contamination risk and extends equipment lifespan. So this is the reason why we have the clean room guideline, and this comes under ISO 14644. We have multiple parts to it. I have only covered ISO 14644-1 to 14644-3, and rest are related to other parameters. Now, another point is that understanding the HEPA filter. When we talk HEPA filter, so we would like to understand what is the basic terminology. The basic terminology is high efficiency particulate air filter, which is a pleated air filter to remove the particle size which are way much lower in sizes, and which are basically the important to perform any operation in the below said industries for life sciences, for microelectronics, for healthcare, and for F&B area. Now, this HEPA filtration is generally, followed by two standards. One is EN 1822, which is an international standard, and in basically in Europe, and one is ISO 29463, which is a global standard. So these two standards are followed very well in all kind of pharmaceutical as well as all clean room applications. And what are the basic grades which come under these standards are EPA filter, HEPA filter, and ULPA filter. So basically, EPA is efficient particulate air filter, which is just lower than the HEPA filtration thing. Then we have ULPA, which is a higher grade of HEPA filters. So uh, basically, EN1822 covers all three grades: E grade, H grade, and U grade, which is EPA, HEPA, and ULPA. Now, coming to the components, mostly, filter frames can differ from application to application, including aluminum, galvanized steel, plastic, stainless steel, and wood. And the frames can be construction. The frame construction can be determined by the application requirements, as mentioned earlier. Then we have different gaskets. So we have solid gaskets like PU. Then we have silicon or gel type gaskets in the HEPA filters. Media separators can be different again. Based on the airflow, we have aluminum separators, which we call deep lead HEPA filters. Then we have hot melt separators, which are being used in terminal, HEPA filters. Then we have glass fiber strings, which are basically used for high temperature filters. And similarly, we have filter sealants through which we seal this entire pack with the frame of particular, when we manufacture any filter. So the most of the common sealants are polyurethane, silicone, and ceramic sealant. So these all these three sealants are based on the temperature range what exactly we are going to pass it through the HEPA filter. PU is for the normal temperature range till 70 degrees centigrade. Silicon is for the higher temperature of 250 degrees centigrade, and ceramic sealants are used for even more for the higher grade or higher temperature grade of filters for temperature around 350 degrees centigrade and above. Now, tips for choosing your HEPA filter. We should be very much clear related to the efficiency that the HEPA filter should actually deliver as per the efficiency mentioned on the certificate. Then it should be individually serial numbered as a proof that the performance has been checked and it has been tested. It should not be a batch tested HEPA filter. It should be a fully traceable, and each HEPA filter should have individual scan test report or the test certificate with it. Then important part is low pressure drop. The better the HEPA filter, the better the media area it contains. It has a better pressure drop, which will ensure that with low pressure drop, your lifetime of the HEPA will increase automatically. And last is long life. It depends on the overall efficiency, and we have to choose and maintain efficiency and performance throughout its lifetime, so your valuable processes are always protected. So this is related to choosing an HEPA filter. Now we'll talk about the standards. Now on the left hand side, you can see EN1822 classification, which I have just explained you, two slides back. That there are three grades. One is EPA, then we have HEPA, HEPA, and then we have ULPA. So what is the common difference between all these three? Is EPA, when we talk about efficiency, it has a efficiency of around 85% at MPPS value. So we have to be very much clear on one part, that whenever we are discussing the efficiency of HEPA filters, if it comes under EN1822 classification or ISO 29463 classification, it should only be on MPPS particle size, which is most penetrating particle size, starting from zero point 0.1 to zero point 0.2 micron, not the zero point 0.3. In most of the cases, in most of the presentations, people generally tend to say that HEPA is generally down to 3.3 micron or something like that. But when we talk about the standards, when we talk about the comparison, so comparison generally says that it should be tested on zero point 0.1 to zero point 0.2 micron size, which is given by the standard itself, that MPPS is the particle size for testing the HEPA. So if you see H13, it's 99.95. Similarly, ISO 29463 has helped to maintain another grade in between H13 and H14, which is ISO 40H. Now you have another grade. Earlier we had only two efficiencies available with us. One was 99.95 and then 99.995, H13 and H14. Now we have ISO 40H, which talks about 99.99 as well. So similarly, there is an addition of grades in between the two earlier EN1822 filter classes. Just like if you see H14 and then ULPA 15, we have another grade 99.999. So it should have a strict equivalence with EN1822 and ISO 29463. We should test our particles on MPPS. Why I'm emphasizing on MPPS is, the lower the particle size it will cater, the better the efficiency you will get from the HEPA filter. And then we have the local value, which is a global efficiency, we generally say, which helps us to determine the minimum efficiency what we can get out of a HEPA filter. In this case, if I calculate the 5% of global efficiency related to this, it should be coming around 99.92. And the leakage factor which Camfil uses for, or I can say the global efficiency local value which we use as in our product, is 2. So which is even better than the grade which is classified in the standard. Now, what are the strengths and how we should check the correct way of scanning a filter, or having better clarity whether what kind of HEPA filter we are using and how it is performing. So Camfil has a unique feature that we generally use, is it is computer controlled system. We don't do any manual interference while testing the filters. We don't test it manually, or just write an test certificate saying that it is a HEPA 13 or HEPA 14 filter. We have a proper computer control system where we have 4 to 5 particle counters, and these counters detects leak, measures pressure drop, and gives you the overall efficiency of the filter, and that too edge to edge. So we don't only check the media, we check the leakages as well by running the scanner through one edge to another edge of the filter. And this is where Camfil differs from other manufacturers and give you the the better solution, and the, I'll say, the trusted solution in the market, by giving you the efficiencies written on the scan test report what we produce. So what information our scan test report actually produces is, first we give the description of the test objects, we will give you the reference of the standard, it will be included here, and then we will have a leakage factor, which I just mentioned, that standard says 5, we are giving better than that, we are lowering it to 2. Then we have efficiencies mentioned on the certificate itself, that what is the target value and what we are achieving out of it. And then we have test method aerosol used. We will mention the aerosol here, that we are using DHS, and then we are using what kind of sampling instrumentation is being used, that is also mentioned in the certificate. So this is the sample, this is the actual certificate which you get when you place order on us for the HEPA filters. So on the left hand side, you can see the model name, serial number, targeted efficiency, then delta P, what is the target based on that. Then we have MPPS mentioned here, that it is 0.18, not the zero point 0.3, which generally people or the other competition generally provides. So particles upstream and downstream is mentioned here as per the CFM, and CFM is mentioned here. What is the CFM of this particular filter, at what air velocity CFM we are testing this filter. Based on that, you will get the pressure drop values over here, and then the class which we are maintaining, is it H14? If it is H13, you will see H13 here and 35H, and if it is H14, then you will find 45H here. So filter is leak free, temperature of the room where it has been manufactured, particle limit. So this particle limit will come after having a scanning, that how much is the particle permissible to come out of the filter when we are talking about H14, which is 99.995, based on the upstream and downstream concentration. So it is mentioned here 43. So this is the particle count, it should not exceed more than that, and that is how we are allowed to have a particle penetration of around 85 particles from this filter. But we test it on 43 to make it double sure that the filter are safe to use, and there's no smaller any kind of issue related to the particle. Even a single particle should go more than the limit which is mentioned here. So this is how Camfil is generating the certificates. Then you can see we are mentioning the test instrument user, operators number, the test machine here, operator number is here, this is the operator's code. So everything is mentioned in the certificate, which is only being provided by Camfil, which is our generally the USP for selling these filters. Now this is the pharma solutions which we are offering in the life science company. So mostly we have mega lamps. This is the model for our mini pleat HEPA filters, and this is a general view of a clean room area, which starts from air handling unit, giving the unidirectional ventilation to different areas. Then we have a packaging area, we have wraps, we have aseptic filling area, then we have sterilization preparation area, then we have washing preparation area, and this is the airlock. So for each and every section, we have a product to offer. It starts from mini pleat HEPA filters. Then second is our HEPA housings. Third is fan filter units, which we provide for laminarity and other application. Fourth is depyrogenation tunnel high temperature filters, which we provide in most of the injectable companies. Then we have exhaust and recirculation bag in bag out units, and wall mounted return BIBO units. So we have all the solutions related to injectables as well as for API companies, where starting from pre-filter to last BIBO unit, we can provide all the equipment from our side. This is we have been delivering almost 10,000 air filter products and solutions every year, and millions of filters are delivered every year to the people, and they are quite satisfied with us. 60% is our repeat customers, the one who generally uses our filters. They don't go anywhere, they trust Camfil like anything.